Here we go. Guys, this is the fundamental theorem of algebra. This is everything that you have learned in Algebra 2. We're just putting it all together. There's nothing new here. It's just a conglomeration of everything. So as we go through this, it might seem a little overwhelming, might seem like a lot, but you guys will be fine, I promise. I promise, promise, promise. Okay. You already know this. If f of x is a polynomial of degree n, where n is greater than 0, then f of x has precisely n number of roots. All that means is the highest exponent tells you how many zeros there are, how many solutions, how many roots. We're just going to do a lot of factoring today, okay? So if I look at these as solutions or roots, on your test, it said to write your answer as I think it was like a product of linear factors or something like that. That's just the step before you solve. So all of you did that in the process of solving your answer. But you can have real zeros and non-real zeros, or imaginary. How do we know they're imaginary? Because there's an I in it, yes? You have rational and irrational. You might have a square root or plus minus square root 2. Okay, that's fine. On the graph, that's in between 1 and 2. Am I expecting you to know what the square root of 2 is? No. But you guys need to understand that that is an answer, and it's a real answer. The only ones that are not real are the ones that have eyes, that are imaginary.
Where does the x go?
What do you mean?
On the two imaginaries, where does the x go? Is it just...
They're equaling it to 0.
They're equaling it to 0.
Oh,
yeah.
So that's fine.
Yeah. Yeah. So if you have... Yes. Okay, so if I look at this, and I said to you, using the fundamental theorem of algebra, find the exact number of zeros. Guys, what does that mean to do? Find how many zeros there are. Factor it. How many answers should I get for this problem? 3. Okay? So I'm going to say 4x cubed plus 2x equals 0. What do I look for first? How do you factor? Greatest common factor. What do they both have in common? 2x. So take out 2x. I'm left with 2x squared plus 1. Yep. Can I factor 2x squared plus 1? No. So we're going to set them both equal to 0. 2x equals 0. 2x squared plus 1 equals 0. So over here I divide by 2. And x equals? Over here I'm going to subtract 1. 2x squared equals negative 1. Divide by 2. Yes? So x squared equals negative 1/2. And then how do I get x by itself? Take the square root. So x equals what? I like that. Okay. And it's plus or minus. Good. You can leave. I'm not gonna. You don't. You don't have to break this down or anything right now. I'm just trying to prove a point. How many zeros do I have here? 3. Do you guys see all 3 of them? 0, positive I, square root of 1/2, and negative I, square root of 1/2. Yes, sir.
Wait, don't you just couldn't you just write it as 1/2 I and plus or minus in front? Because isn't it already implied that with the I on the side it's negative, like square root negative?
No, because it's positive I, root 1/2, and it's negative I.
So the i's on the outside.
The i's on the outside. That negative is not accounting for the negative inside the radical.
Oh, so
that's what the I is.
Oh, okay, so then how do you know the I is on the outside if it looks like it's on the inside in the first one?
No, it's on the outside of the radical. I mean, it's in between the plus or minus, but it's on the outside.
And I'm just wondering why only because it looks...
Okay. Solve the function. How many answers should I get for A? 2. All right. Can I factor this? No. Guys, this is not the difference of perfect squares. It's not x plus 6 and x plus 6. If you multiplied x plus 6 times x plus 6, you get x squared plus 12x plus 36, not x squared plus 36. So this case, you say x squared plus 36 equals 0, right? How do I solve this? Okay. God bless you. Minus 36 from both sides. So you have x squared equals negative 36. Take the square root. So x equals plus or minus what? 6 what? 6i. I have two solutions there, yes? Positive 6i, negative 6i. Are they real or imaginary? Imaginary. Good. What about the next one? 3 answers. Good. I can factor out an x. There's a GCF. So I have x times what? X squared plus 25 equals 0. Can I factor x squared plus 25? No. So I have x equals 0 and x squared plus 25 equals 0. So subtract 25 from both sides. X squared equals negative 25. Square root, good. So x equals what? Plus or minus 5i. Good. So I have 2 answers there and 1 there. How many zeros did I find? 3. What do you know about those zeros?
One is real, 2 are imaginary.
Good. Good. Yes, sir.
Okay, so I kind of see it now. The reason why it was the I on the outside is because it was a fraction. Like you couldn't just put a fraction into it.
Yeah, I thought once you saw another one. Yeah.
Yeah, because I didn't.
No problem. All right. What's the first thing I'm going to try and do here? I'm going to try and factor. What are the factors of 1 that multiply to give me 1 and add to give me negative 3? Nothing. Okay, if it doesn't factor, there's no GCF, blah, 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 blah. What do I use? The quadratic formula. Okay, so what is your A term? A is 1. What's B? Negative 3. And what's C? All right, how many answers should I get here? 2. All right, so I'm going to say negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 1, right? You guys agree? All over 2 times 1. Yes, sir.
Is there supposed to be a square on top, like, next to the 3?
It is.
Oh.
To the little 2.
Oh, I didn't see on the inside. No, I thought I was talking about the outside one. That
No.
one wasn't
No.
Okay.
So let's simplify this. Negative gives me a positive, right? Plus or minus. What's negative 3 squared? 9. And 9 minus 4 is? Good. Over 2. Can I simplify it all? I can't? You guys sure? Yeah. You're right. Just making sure. So how many solutions do I have? Okay, so how many solutions do I have here? 2. All right. Last period, someone's like, how do I have 2? If you guys need to write it out to see it, do that. It's 3 plus root 5 over 2 and 3 minus root 5 over 2. Yes, sir.
Could you then write it as 3 over 2 plus 5i, and then 3 over 2 plus, minus 5i?
It's not imaginary, though, because there's no negative under the radical. But you could write 3 over 2 plus root 5 over 2. Or you could do, if you wanted to separate it, you could. Like Sean's saying, could I write it as 3 over 2 plus root 5 over 2 and 3 over 2 minus root 5 over 2? Absolutely. Either way. Sometimes, guys, I think it's a good idea to just separate it just visually so you can see if you can simplify. Because sometimes you might be able to simplify, if that was a 4, right? If it was 4 plus root 5, you could simplify the 4 and the 2, but you can't the root 5 and the 2. So sometimes that's helpful. Yes? Okay. That's, I'm not going to worry too much about it, but it would just be like, you would write it like this. X minus 3 plus root 5 over 2. When you guys solve, you do that anyways. Like, one of the problems on the quiz or the test was like this. this is writing it as a product of linear factors, and then you would go ahead and solve it. So in the process of solving, you write it as a linear factor anyways. So that's where I
On the test, you like write that part instead of this one. Wait, doing the x plus 3, x minus 3.
but then it's going to ask you to solve it and write as a product of linear factors. So you're doing the same thing.
Can we like put it as two separate?
No. Just do the work and I'll see it. Yep. Okay. What about here? Can I factor this one?
Isn't 8 or no? Wait. Oh no. No. 81 is 9, not 8.
I can factor it, right? There's no GCF, but I can factor. What times what gives me 16x to the fourth? 4x squared and 4x squared, right? What times what gives me 81? 9 and 9. This is the difference of perfect squares. So I have 4x squared plus 9, 4x squared minus 9, right? If you can factor, go ahead and do it. And then we just solve this. So set each one equal to 0. 4x squared plus 9 equals 0. 4x squared minus 9 equals 0. So I'm going to simplify this. What do I do? Plus 9 on both sides. 4x squared equals 9. Divide both sides by 4, right? Now what? Take the square root. If I take the square root, what goes on my answer? Plus or minus. What's the square root of 9? 3. What's the square root of 4? Okay, so how many solutions do I have there? And they are both what? They're both real. All right, so I go over to this one. What do I do on the left-hand side? Subtract 9, right? So 4x squared equals negative 9. Divide by 4. So what? Take the square root. When I take the square root, what goes on my answer? So I have plus or minus. What is the square root of 9? 3. What's the square root of 4? 2. But since there's a negative, what goes on my answer? There you go. So I have 4 answers. 2 of them are real, and 2 of them are. There you go. Good. We good? Okay. Let's see. Find all the possible zeros. So that means to factor. So what do I do? It's the first thing we look for. If we're going to factor, what's the first thing we look for? Greatest common factor. Is there one? No. Is this a trinomial? No. Is it 4 terms that I can group? No. So what do? Can't do the quadratic formula because there's bigger exponent than 2. Good thinking. Synthetic division. Okay. What am I going to synthetically divide? Of?
16.
Good.
I don't know why I would use the factors of 16. Why couldn't I use the factor of 4?
You're going to use the last number.
Oh, okay.
So what are my factors of 16?
4, 1.
Plus minus 1, 2,
4.
8. Just kidding.
2, 4, 8.
4, 8, 16. I'm going to start with 1. See if it's a factor. We're going to synthetically divide. So I have 1, negative 4, 8, negative 16, positive 16. Quickly, 1 times 1.
1.
Negative 4 and 1. Negative 3 and 1. 8 and negative 3. 5 and 1. Negative 16 and 5.
11.
Negative 11 and 1.
11. Negative 1.
Is this a factor?
No.
No. Okay, let's try negative 1. So 1, negative 4, 8, negative 16, positive 16. Bring down the 1. 1 times negative 1. Negative 1. Negative 1 and negative 1. Sorry, negative 4 and negative 1.
Negative 4.
Negative 5 and negative 1.
5.
8 and 5. 13. 13, negative 1. Is this going to be a factor?
No.
Okay. So now let's try 2. 1, negative 4, 8, negative 16, positive 16. I published the teacher copy of the notes. because I know this is a lot to write.
2.
Bring down the 1. 1 times 2 is
2.
negative 4 and 2.
Negative 2.
Negative 2 and 2.
Negative
8 and 4. Negative 4.
4.
4 and 2.
8.
Oh, negative 16 and 8. Negative 8 and 2. Is this a factor?
Yeah.
So x equals 2.
No, just 2.
You just, yeah, but just leave it. It's x equals 2. Now what? How many more answers do I have? I have 3 more. So what do I do?
Take that
Plug
one.
it in.
What do you mean plug it in?
You take that one that you just found. Like
Take-
you have a new.
Okay, what's my new equation?
1x cubed.
Yep,
Negative 2x squared.
perfect,
Plus 4x minus 8.
perfect. Now, we could do synthetic division again,
Or you just have
or I would just factor it, right? If you can, I would do that. Let's group it. First 2, second 2. What do I take out of x cubed minus 2x squared?
X squared.
Good. And I'm left with x minus 2. All right, what do I take out of 4 and negative 8?
4x. Or 4.
So plus 4, I'm left with x minus 2. Agreed? So I write x minus 2 one time, and then what happens with the x squared and the 4? It gets its own parenthesis. Can I factor x squared plus 4?
Yeah.
No.
No. No.
I can set it equal to 0 though. So I have x minus 2 equals 0, and then I have x squared plus 4 equals 0. So here x equals 2, right?
And x equals 2. So it's more.
So, very good. X squared equals negative 4. Now what? Square root. X equals plus or minus 2i. There are my 4 answers. X equals 2, x equals 2, and x equals plus or minus 2i. I have 2 real, 2 imaginary. Do I have multiplicity?
Yeah.
Yeah. Again, I know it's a lot to write. I published the teacher copy of the notes, so you have everything written down nice and pretty. It's there for you. And then you also have a video. This is going to be important. What we're going to do here, guys, is we're going to go from the answers to the polynomial. So you guys did this in Algebra 2, and I know for some of you it was probably a little confusing. I'm going to show you a shortcut tomorrow. It's on the teacher copy of notes as well. Some of you will like the shortcut, some of you won't, so I'm going to do it the long way now. But what this is saying to you is if I have a 0 and x equals 2, right, that's real. Agreed? Okay, so if I was going to write that as a binomial, what would it look like?
2 plus 0.
Think about if I move this 2 over here, how would I move it?
Oh.
X minus 2.
This would be x minus 2, correct? If I went backwards? Okay, so if you have an imaginary, like 3 plus 2i, they tell you have an x or a 0, whatever, at 3 plus 2i, you have to always account for the conjugate. So if they tell you you have one imaginary, you know you have a second one. What's the second 0 that I have to account for? What's the conjugate of 3 plus 2i? 3 minus 2i. That only happens with our imaginaries, but you guys have to remember that. So if you have a question like this, and they say, find the polynomial function with real coefficients that has the given zeros, they're giving you what x equals. They're telling you that x equals 3, and that x equals 3 plus I. Is one of those zeros imaginary?
Yeah.
Yes. So if you have an imaginary 0, what do you have to account for? The conjugate. So I also have a 0 at x equals 3 minus I. Okay? Only counts for our imaginaries. But they're telling you what the 3 answers are. We're going to work backwards to get what the whole long polynomial is. So if I'm going to write, and I want you guys to pay attention to this, and again, I told you I'll show you the shortcut tomorrow, but if I'm going to write x equals 3 as a binomial, if I move this 3 over here, what does my parenthesis look like? x minus 3. Good. You just change the sign. Now look, this is one number. It's a complex number. It has a real part and an imaginary part. But is it positive or negative? It's positive. So if I move this over, my parenthesis says what?
X minus 3 parentheses 3 plus 9.
Okay. You guys see that? Then if this is, again, this is positive. So if I move it over, what does that become? X minus 3 minus I. It just stays just like that. You're moving the whole thing over. Now we'll distribute the negative, but I just wanted to show you guys when you move it over, the 3 is actually, I stopped the video that time. The 3, do you see how it leads with the 3? The 3 is positive in both situations. So I'm going to leave x minus 3 over here by itself. And I'm going to worry about my second two parentheses. So if I rewrite this, I have x, what do I do with this negative? Okay, so it's minus 3 minus I. And then here I have x what?
Minus 3 plus 9.
Yes, sir.
Is this what we were supposed to do in the 3.4 homework?
No.
Okay, because I was worried if I did it wrong.
No. Okay, leave your x minus 3. Just leave it. We'll deal with it in a second. Now, guys, all we're doing is distributing. That's it. What is x times x?
X squared.
Okay. What is x times negative 3? Negative 3x. What is x times I? Ix or xi, however you want to write it. Now, negative 3 times x. Negative 3 times negative 3.
Plus 9.
Negative 3 times I. Negative 3i. All right? I times x. Negative ix or xi. Negative I times negative 3.
3i.
Plus 3i. Negative I, positive I.
Negative I squared.
Okay.
Oh, so it's 1.
So, again, we're going to keep our little x minus 3 just hanging out here because we're trying to get to our original problem. Now, let's clean up. Is there anything that has an x squared? Just the x squared by itself, right? Okay, so rewrite x squared. I have a negative 3x and a negative 3x. That gives me what? Negative 6x. I have a positive xi and a negative xi. Cancels out. I have a negative 3i and a positive 3i. Cancels out. Good. And if I have I squared, what does that equal? Negative 1. So you guys agree this is minus negative 1. Right? So it's plus what? This is just at the end here.
So it's plus 7 plus 9.
This is plus 1 right here. So I have a 9 and a 1. That gives me what?
7.
What do you guys notice happened to all the i's?
They're gone.
They canceled out. I'll show you a shortcut tomorrow. Again, I'm not trying to confuse you, but you can just distribute it every time. But now we just distribute one more time. What's x times x squared? X cubed. What's x times negative 6?
Negative 6.
Good. X times 10. Negative 3 times x squared. Negative 3 times negative 6x. Negative 3 and 10. So I'm left with x cubed. What? Negative 9x squared plus 28x minus 30 equals 0. What you guys just did was you took your zeros, you took your answers, and you worked backwards to get the long polynomial. Generally, what we've done before is I would give you this polynomial and say find all the zeros. You guys just went backwards. This is just a matter of algebra. We're going to work on this more tomorrow. I'll give you guys homework tonight to practice this. We will go over that and 2-4 tomorrow. All right? One more thing I want to talk about. When you have complex zeros, they give you one, and then you have to find the remaining zeros. You're going to have to use long division. Okay? They're going to give you imaginary zeros, and you're going to find a real one. This will work out every time. So if it doesn't, then you did something wrong. You need to check your work. I'm going to do one of these, and then I will leave the second one for you guys to practice, and it's on the teacher copy of notes. But how many zeros, how many answers do I have for this problem? 3. They gave me 2 of them.
Plus 5i.
Okay, they gave me x equals 5i. So that means they also gave me another 0. Where? Good. X equals negative 5i. So the first thing you're going to do is you're going to take your complex zeros and you're going to multiply them together. So I'm going to create. So the first thing I'm going to do is I'm going to write 2 binomials. What do my 2 binomials look like given my zeros? X plus 5i and x minus 5i. So again, we're going to work backwards here. They gave us the answers. We're going to figure out what the long problem is that I'm going to divide into. So what is x times x? X squared. What is x times negative 5i? Okay. What's 5i times x? Plus 5xi. And then what's 5i negative 5i? Negative 25 what? I squared. Okay, so what happens with my 5xi's? They cancel out. And then I have negative 25i squared. I squared is equal to what? Negative 1. So I cross this out and put a plus. So I have x squared plus 25. Okay? This process will be the same thing every time. So now I know what 2 of my zeros are. They gave me these 2. I'm trying to find the third one. So now I have to take x squared plus 25 and divide it into 2x cubed plus 3x squared plus 50x plus 75. Now you have to keep yourself organized. Okay, watch how I do this. Last period they were like, what? Then, oh, okay, that makes sense. So watch what I'm doing. First term into first term. X squared times what gives me 2x cubed? 2x. Agreed? Where am I going to write my 2x? Above 2x cubed? Above 3x squared? Or above 50x? Why above 50x? You're right. You want the exponents, you want the exponents to be lined up, right? So I'm going to write 2x right here. So now we're going to subtract. So what is 2x times x squared? 2x cubed. I'm going to write it underneath the x cubes, okay? Now I have 2x times 25. What's 2x times 25? 50x. Where am I going to write that? Underneath the 50x. Because we're going to subtract, right? So I have to keep my terms lined up. You put 0 in the middle. Be plus or minus. Doesn't matter. I'm just going to put 0. Now before I subtract, what do I have to do with that negative sign? So distribute, 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 distribute. Yes, sir?
Why is there a 0 in the x squared?
Because you don't, it's a placeholder. There is no x squared. When you multiply 2x times x squared is 2x cubed, and then 2x times 25 is just 50x.
So now you should have 3x squared.
So if I subtract now, what's 50x minus 50x? 0. What's 3x squared minus 0? 3x squared, good. And then what's 2x cubed minus 2x cubed? 0. What do I do with 75? Bring it down. If that 0 there confuses you, just don't worry about it. Don't write it. We're going to do the same exact thing, guys. First term into first term. X squared times what gives me 3x squared? Plus 3. So right above the 75, plus 3. And now we're going to multiply. What's 3 times x squared? 3x squared. What's 3 times 25? Before I subtract, What do I do? Distribute, distribute, distribute. So what's negative 75 and positive 75? What's 3x squared minus 3x squared? So this is the last 0 right here. How do I find out what that 0 is? 2x plus 3 equals 0. Now what? Minus 3 from both sides. 2x equals negative 3. Divide by 2. X equals negative 3 over 2. So what's going to happen when you guys do this? You will have, they'll give you a complex solution. They'll give you the imaginary. So you have to account for both the positive and the negative, or the conjugate. And then you'll find the last solution, or the last 2 solutions, but they'll be real. So you can solve it. All right, I know this is kind of weird, but it's nothing that you guys haven't seen before. It's just kind of putting everything together. Yes, sir.